Welcome to the world of technical and engineering drawing with draft and dialogue. As your instructor, I am here to guide you through the intricacies of design and precision. Let's embark on this enlightening journey together. Today, let's dive into the world of orthographic projection, a fundamental technique in technical drawing that transforms three-dimensional objects into precise two-dimensional representations. By projecting lines from these objects onto perpendicular planes like top, front, and side views, we can capture their features with accuracy. Orthographic projection plays a pivotal role in effectively communicating design and manufacturing details, aiding engineers, architects, and designers in conveying dimensions, shapes, and features meticulously through multiple viewpoints. In this method, each view, be it the top, front, or side, portrays the object as if it were projected onto a plane directly in front of it, ensuring precise measurements and a clear depiction of all aspects of the object. Mastering orthographic projection is a cornerstone skill in technical drawing, enabling the creation of detailed and precise engineering designs and plans. Let's now explore the transition from isometric views to orthographic views, a common task in technical drawing and engineering design. This process involves translating a three-dimensional object depicted in an isometric view into two-dimensional orthographic views like the front, top, and side perspectives. Here's a step-by-step guide to navigate this conversion seamlessly. When working with isometric views, envision three sets of perpendicular lines representing the object's x, y, and z-axes, aligned parallel to the object's edges and set at 120-degree angles to each other. Now that we're in the first quadrant in box form, we'll unfold it and turn it into two dimensions to make it more readable. For the sake of clarity, let's go step by step. Now, let's move on to drawing orthographic views from isometric views. Begin by visualizing the object in its isometric form, capturing all three dimensions. Project or extend the z-axis lines out of drawing. Create a 4 cm by 4 cm square out of the drawing after projection, which is the largest size for both width and depth. Next, identify which plane may be seen from top. If the length of the x and y-axis lines is more than 0, the plane may be seen from above. If not, it cannot. Therefore, check the length of the plane to determine if it is visible from above. Is the y-axis and x-axis line lengths present in this plane, plane M? You're right if you said no, as it misses an x-axis line length. To put it another way, this plane is invisible from above. The next plane, W, is therefore visible from above since the x-axis and the y-axis line. Similarly, on the x-axis and y-axis line length, therefore it's visible from top. Thus, planes M and N have dimensions of 1.5 centimeters on the x-axis by 3 centimeters on the y-axis for to rectangle. And since we are utilizing the first angle projection method, our top view drawing point is here. Then, using the same technique, proceed to draw another plane. Using the same previewing rule, check whether the same plane O and the same inclined plane K can be seen from top. To remind you of the rule, if there is line length on the x and y axes, the plane may be seen from top. Otherwise, it would be invisible from top if one of them had no lines. So there is a line in both x and y in plane L, y-axis. You're right if you answer yes, which means that this plane can be seen from top. What about J-plane? If you answer that it's not visible, you're right because the y-axis line is missing. And what about the identically inclined plane K? You are right if you say that it is visible from the top since there is a line at the bot x and y axes. Therefore, in top view, draw the planes L and K that are visible. Now that the front view is the primary consideration, the plane seen from the front if it is drawn on the y and z axes, or if it contains lines on both axes. Otherwise, it cannot be seen from the front. Then the both y and z axes of the late check plane have lines. We can claim that the planes are visible from the front side, since we can see that both of them have lines on the y and z axes. How about planes M and N? Then, does it have lines on the y and z axes? If the answer is no, you are correct, since the planes are either not lined up on the z-axis. In addition, the y and z axes are not used to create the planes. Therefore, draw the front side's visible planes I and O. In order to complete the front side, which planes are still required? Can you see the U and L plans from the front? If you answer no, you are correct, because neither the y or the z axes are used to build the planes. Therefore, draw planes G and F to complete the front view. On the opposite side, draw the same 0.5 by 1.5 rectangle. The planes are formed with two axes. So keep in mind that if they are drawn with the z and y axes, they are visible from the front. If they are made with the z and x axes, they are seen from the side. Lastly, the plane can be viewed from above if it was made utilizing the y and x axes. This is the final plane for the front side, and as we can see, it is inclined. Draw the other in the same manner, and this is how it turns out. The side view is the final view that has to be drawn. The lines are projected from top and front perspectives to create the side view drawing. We can simply gate the locations where the view can draw after projection. As previously stated, while drawing a side view, take into account lines Z and X or ignore line Y, which turns into a point when seen from the side. As we can see, the first plane is drawn using both the X and Z axes, or it has a line in both that indicates that it is visible from the side. This plane is created using the y and z axes. Therefore, there isn't a line on the x-axis to draw it, making it invisible from the side. Instead, we can only see a line on the y-axis, which indicates that it is not a plane. The last plane that has to be drawn is then here. Since the initial plane covers the remaining and final plane from view from the side, we can show this information using hidden line. When we use the hidden line sign hush, these two solid lines are not visible from the side, since they are covered by blue lines. Because it is protected by the first plane with the blue line, the plane with the red line cannot be seen from the side. The remaining lines, however, are not covered by other blue lines, so we can see them from the side. For this reason, the lines are made hush to indicate that they are visible from the side, and that the other plane with the blue line is shielding them. Thank you for your dedication and enthusiasm in exploring the intricacies of orthographic projection with draft and dialogue. Remember, precision in design leads to excellence in creation. Keep sketching and innovating.